Okay, so what is the student's T distribution? So the student's T distribution is similar in shape to the normal distribution. So the normal distribution is both symmetrical and bell-shaped, but the student's T distribution is just symmetrical. The reason why it's not bell-shaped is that it can change shape based off of the sample size. The student's T distribution has more area in its tails than the normal distribution. The tails of the student's T distribution look a little thicker. Unlike the normal distribution, the shape of the student's T distribution changes based on sample size. However, as sample size increases, the student's T distribution approaches the shape of the normal distribution. So what I've got here in this picture is you can see that there's a dashed line. Okay, this dashed line right here. That is a graph of the normal distribution. Okay, the dashed line is the normal distribution. The purple, red, and blue lines are the student's T distribution. But the reason why there are three different ones is the purple one is the student's T distribution when you've got a sample size of 2. The red one is the student's T distribution when you have a sample size of 4. The blue one is the student's T distribution when you have a sample size of 10. So what you can see is that as the sample size goes up, right, as the sample size gets larger, the student's T distribution is approaching the shape of the normal distribution, right? You can see we're going from purple to red to blue. That's going up and it's approaching the dashed line. Whereas on the tails here, we're starting at purple, which is high, then we're going to red, which is lower, and then blue, which is lower, and it's approaching the normal distribution, which is the dashed line, which is the lowest. So you can see in the tails for the student's T distribution, the tails are thicker. But as the sample size goes up, they get thinner and thinner and thinner, approaching that of the normal distribution. Okay, let's see here. And, you know, when you have a sample size of about 30 with the student's T distribution, it approximates that of the normal distribution. So you can see as the sample size is going up, imagine if it keeps going up, this peak up here at the top will get closer and closer and closer and closer to the normal distribution. And down below, it'll get closer and closer and closer until it's on the normal distribution itself. Or, you know, so close to it to, you know, not really make any difference. So with the student's T distribution, there's a parameter, there's a parameter called degrees of freedom. Okay, and it's abbreviated DF. And it's used with the student's T distribution. Degrees of freedom is calculated from sample size. So the degrees of freedom is equal to the sample size minus 1. The student's T distribution is used in scenarios when the population standard deviation is unknown and or the sample size is less than 30. So remember what I just told you about the sample size? When the sample size is about 30 or higher, the student's T distribution approximates the normal distribution. You remember previously we talked about the empirical rule? Well, the empirical rule does not apply to the student's t-distribution. And to kind of, maybe hit that home, let's look at this normal distribution and the student's t-distribution side by side. So remember that the empirical rule is sometimes called the 68, 95, 99, 7 rule. And the reason why that is that because, I guess, between two standard deviations from the mean, so two standard deviations up, two standard deviations below, the area in between is 95%. So you can see with the normal distribution, when we have a confidence level of 95% in the middle, we have critical values of 1.96 and negative 1.96. So these two critical values here and here define the boundary of a 0.95 area in between them, between there and there. Now, if we skip on over to the student's t-distribution, you can see the center, we also have an area of 0.95. So even though the area is identical, the boundary, the critical values that create an area of 95% are different. So you can see here, in order to have an enclosed area between the critical values of 0.95, we need to have a t-score of 2.26 and negative 2.26 for this critical value and for this critical value. So you can see how, these values are different, right? So we have the same area, but the values are different because there's like a different thickness in the tails between the normal distribution and the student's t. And this particular picture we're looking at here, this is with a sample size of 10. And remember that the degrees of freedom is equal to the sample size minus 1. So if the sample size is 10, 10 minus 1 is 9. So that's where 9 degrees of freedom comes from. So also very similarly is that if we calculate a z-score, on the normal distribution, that's the formula we use. But notice that to calculate the z-score, we need the population standard deviation. But we use the student's t-distribution when the population standard deviation is unknown. So when the population standard deviation is unknown, then we use the sample standard deviation in its place. And you'll see that all the other components for the t-score is the same as a z-score. Okay, so these are all of the similarities and the differences between these two distributions here. And I hope that it helps to see these two distributions side by side. You can see the areas where they're exactly the same, but even though in these areas they're exactly the same, the differences in the critical values. And, just like before, when we're given an area and we want to calculate a value on the number line, we need to use an inverse distribution function, when we were working with the normal distribution, we would use inverse norm. But now, since we're using a student's t distribution, we're not going to use inverse norm. We're going to use inverse t. And notice that both inverse norm and inverse t need you to put it in area, because the whole point of inverse functions is to take an area and create a value on the horizontal axis on the number line. But now, instead of asking for the mean and the standard deviation, now it's asking for degrees of freedom. So the degrees of freedom is the sample size minus 1. And this inverse t function is the native inverse t function. And notice it doesn't give you left, center, or right as an option, which means it's always calculating area from the left. The numworks calculation, or the numworks calculator, I'm sorry, you go in the distributions app, and instead of choosing the normal distribution, you just go a couple options down to the student's t distribution. And it'll ask you for the mean and standard deviation, which is 0 and 1. No, wait. No, it shouldn't ask you for that. Okay, this is what the normal distribution screen looks like. After you choose student's t, it's just going to ask you for degrees of freedom. Okay. And after that, the student's t distribution looks very much like the normal distribution. It still acts the same way. You choose your area, left, right, or center. You put the area in here if you're doing an inverse function. If you're using a CDF function, you put your value there for a CDF function. Okay. And this one lets you choose left, center, and right. Okay. So the one thing I might add is, if I've had the opportunity to install my programs in there, if we look at, let me turn this one on. If we look at my programs, I added an inverse t function. This is another one that I've written. And you put your significance level. So we'll put maybe an area of 0.025. Degrees of freedom, maybe we'll do 12. And we want it in the right tail. So this program gives you the option of whether you want to calculate the t critical value on the left or on the right, or if you want to put in a confidence level and have it two-tailed. But you just wait a second, and it's going to calculate a t-score. Looks like it's taking a little bit. There we go. And so this is a positive t critical score. And this is what the t critical value would be. And this would be the boundary between the significance level on one side and the confidence level on the other side. Okay. All right. So in short, this describes, what a student's t distribution is. It changes shape, but as you can see, it's symmetrical. It's the same on the left-hand side as it is on the right-hand side, but it does change shape based off of the sample size. It's used in cases where the population standard deviation is unknown, or you're working with sample sizes less than 30. You can see that calculating a t-score will give you a different value than if you were calculating a z-score with the same areas. And your calculator can do the inverse and the CDF functions just fine. Yeah, let me show you the CDF function really quick. So, with the Texas Instruments, if we go to the distribution functions, you'll see there's inverse T and there's TCDF. That's option 6. And again, with the NumWorks calculator, I guess just to be complete distributions, let me back out there. And you want to go down to students T, put in your degrees of freedom. And you can see now you've got the students T distribution with the degrees of freedom that you put in. And now you can do a CDF, by entering a value here, or you can do an inverse distribution function by putting in an area there to the right. And then just choose, where the area is on your distribution. All right. So I think that's it for this part. Yeah. Let me know if you have any questions.